All right. So here are the slides. Okay, so now let's look a little bit at the impact of security on software, because software is definitely everywhere, right? If you think of an aspect of your life that is not driven by software, it becomes very hard to do. Banking, healthcare, and finance has a lot of software. Travel, entertainment, communications. So this is where it gets creepy, right? Automation, home automation, alarm systems, fire detection, surveillance, military. Also, you see a lot of software in cars these days, right? Tesla is doing some really cool things with self-driving cars. Of course, you might ask yourself, what could possibly go wrong? This could happen. It's never a good time. But if you remember a few years back, at DEF CON, some researchers show how they could break a Jeep. You're driving on the freeway and somebody's driving your Jeep for you, right? A lot of things can go wrong there. And then they did it the next year again. So, let's look a little bit at your exposure, right? You have a business, and your business has data. Presumably, if you've done things right, it's protected by your cloud. And inside your cloud, you may have an internal application to manage your inventory. You could have a customer relationship management application. So your staff is going to go in through VPN right here, and they're going to use your internal applications, right? Those are not exposed to the world, and that's a good thing. So now if attackers want to crack your business, they're going to go through one of your exposed ports, which will be port 80 and port 443 for your customer-facing web applications. And then they're also going to go after your employees, right? They're going to send phishing emails and click here to change your password, right? And then they're going to go here. So today, we're just going to look at web application security, right? InfoSec is a vast field. We're just going to focus on web applications. So you can imagine what happens when somebody cracks your web application, right? Exfiltration. Oops. You have customer data, you got intellectual property that leaks out. People are transferring money to their account. Financial crime. Business disruption is also a big thing. And advanced persistent threat. So they hack your web server and they just kind of hang out there to gather more data or to do more nefarious things. So there have been a lot of high-profile security breaches. I have a bunch of links to articles talking about those. So I'm not going to depress you with those. Yahoo. In the United States, the Office of Personnel Management had a really high-profile leak. Equifax, it's a credit agency. It was just terrible, and that was a straight-up insecure component, unpatched insecure component. It was awful. Anyway, so looking at web applications, what makes them really an easy target? Well, you have millions of them. And scanning your web applications are always on, right? So they're easily scanned. They do have sensitive information behind them. And it's also a big attack surface. If you look at your web application, there's code that you write, there are frameworks that you use, there's the underlying HTTP daemon, right? It's a pretty massive attack surface. There's also this whole thing called denial of service attacks. I have a separate talk on that. It's pretty fun. I'm not going to touch on that here. So we're going to look at strategies to not get owned. Okay, here we go. So the first thing we want to do is educate humans. Okay, that is the very first thing that we need to do. We need to not add vulnerabilities to our applications. Okay, so the next thing that we're going to do is have code reviews, right? And we're going to try to catch vulnerabilities in each other's code. One layer below that, if the two layers above it fail, we hope that we'll have some automated code scanning that will catch the vulnerabilities. Vulnerabilities in our code, in the code that we write, but there are also vulnerabilities in dependencies. So we're going to look at tooling in continuous integration to check for dependencies. Right, so beyond the software that you write, there's also the frameworks that you use, and those are vulnerable as well. Okay, so then, if you don't catch vulnerabilities above, you hope that your automated penetration tests are going to catch vulnerabilities. And if that fails, you hope that your web application firewall is going to catch them. And if all else fails, you hope that you have some logging in there so you can figure out what happened, right? So if you look at this stack, you want to catch vulnerabilities, up here, right? The further down below you go down the stack, the bigger the failure, the bigger the cost of those vulnerabilities. So, and I like to kind of draw a red line, right here at the continuous integration, because the failing below the red line is even more painful. Okay, so we want to avoid that. So we're going to look at all of these. We're going to look at a bunch of tools for these categories. But first, let's look at educating humans. Is anybody here familiar with OWASP? Okay, hopefully soon there will be a lot more hands raised. Definitely do spend a lot of time on OWASP.org. It's absolutely a phenomenal site with a lot of really good resources. And here's what they say. We advocate approaching application security as a people, process, and technology problem. Okay? I think it's a good way to look at it. So they've been around for a while. Please do spend a good amount of time on their site. So every couple years, sometimes every year, they'll publish the OWASP Top 10. It's a list of the top 10 vulnerabilities out there in the wild that get people compromised. Here's the URL to it. So definitely look at it. All right, so now we're going to get back down to tooling. Okay. So the first thing we're going to look at is automated code scanning. There are a lot of tools that you can integrate as part of your continuous integration to do automated code scanning. So here on the OWASP site, they list a bunch of those tools. They list open source tools as well as commercial tools. So you can go there and reference that. But we're going to look at a few here. So SonarQube is great because it's a pluggable architecture, and you can make it work with just about all programming languages, and definitely PHP. So C#.NET has some tools. I'm going to skip Java. So in PHP, there are a lot of really good tools. You got ProgPilot, you got PHP-CS Security Audit, you got Sonar PHP, which is a plugin for SonarQube. And OWASP actually made something called OWASP Web Application Protection. And that's a platform dedicated to scanning source code in PHP. Right? So you could use any or all of those tools in your continuous integration for your PHP project. And it should improve your security by a lot, right? So I got tools in Ruby, I got tools in Python, JavaScript. Okay, so beyond that now, so the automated code scanning, that was to scan the code that you write, right? So now we're gonna look at dependencies, vulnerabilities, checks. So if you look at Composer, does anybody here use Composer? Okay, yeah, all right. So if you look at all the packages that you include in your Composer.json files, any number of those could be vulnerable, right? And you want to know about it, and you want to maybe upgrade them. And so there are a lot of good tools that allow you to do that. So OWASP has a cross-language tool which works with all these languages. In PHP, Rove makes a package called Security Advisories, which works for new packages. And then Friends of PHP has Security Advisory, which is a little bit slower to run because it looks at all your existing packages, right? So you might do an initial scan with the Friends of PHP tool, and then going forward, you might just use Rove's security advisories package to scan all new packages that you include in your Composer JSON. Okay, so that is for checking vulnerabilities in other people's software. Okay, I'm gonna skip these guys. All right, so now we go below the red line, right? This is kind of where the cost of finding bugs kind of gets a little bit higher. So automated penetration tests simply means that you run a script against your web application that could be running in your development environment or staging to try to do outside penetrations, which is the same thing that hackers do, right? So the tools that you might use to find vulnerabilities in your own web applications, hackers are doing it, 24/7 in production, right? If you tail your logs in production, you will probably see a lot of those attacks, right? So they're super considerate. They do it for you, right? I like to put a little MOTD message on my web server that says, hey, while you're here, can you upgrade my PHP 7? That'd be nice. So, all right. Penetration testing. So OWASP made a tool called OWTF. It does not stand for what you might think it stands for. It means Offensive Web Testing Framework. All right? So open source tool you can use. They've also got a project called the Z Attack Proxy. So this one is, you kind of use it as part of your development process. But anyway, you can use both of those for penetration testing. There's also Metasploit, which has been around for a long time. Security researchers and hackers use Metasploit a lot. Metasploit can do a lot more than web application penetration testing. It will do a lot of things, right? But it does do some penetration tests for web applications as well. Okay, so all of these are free open source tools that you can use. Okay, so that was for penetration tests. So now we're going to go one layer down to your web application firewall, or a WAF. A WAF sits in front of your web application, and it tries to intercept hacking attempts and block them. They're kind of a pain to work with because you do get a lot of false positives, especially if your site is like a forum or there's a lot of comments. If somebody puts 1 = 1 in a comment, they might get blocked by the firewall because it thinks you're trying to do a SQL injection, right? So when you work with the web application firewall, make sure you spend a lot of time testing it and customizing it and to look for false positives. But there are a few of them out there. You got modsecurity.org. You got a couple of Nginx plugins here. You got Shadow D as well. So you can explore those. I personally try to stay away from web application firewalls, but they're out there. You can always look at them. Right? Just know to customize them. Okay. All right. So we just looked at tooling, right? At least, even if you don't know all the vulnerabilities that are out there, the tools at least will know a bunch of them, and it should help improve your security posture, right? Remember, do whatever you can to educate yourself. Right? That's what matters the most. But all these tools will also help you out to get a better security posture. All right. So now let's go back to educating humans and trying to understand vulnerabilities. So we're going to look at low-level vulnerabilities and then application vulnerabilities. In low-level vulnerabilities, we're going to look at a few things. We're going to look at injection vulnerabilities like SQL and no SQL injections. cross-site scripting, and CSRF. Is anybody here familiar with CSRF? Okay, I'm probably going to skip over that section so that I can have more time toward the end. But I have a bunch of slides you can look at as well. And then cross-site scripting, is anybody familiar with that as well? Okay, yeah, most people are. Okay, good. All right, we're going to focus on injection vulnerabilities. You ever seen this cartoon, right? Old school, right? It's been around for a while. Good old Bobby Tables. Okay, so obviously the impact of an injection, you can leak, destroy data, escalate user privilege. And the vector is to basically insert a variable into some kind of SQL string. And that's kind of what it would look like in PHP, right? Where ID equals, and then you put the user ID here, and then an attacker can put whatever they want in user ID and then completely subvert your SQL query, okay? People say, oh, you should sanitize inputs. No. Sanitizing inputs is far from enough. It's not reliable because you can't always do it, especially if you run user-generated content. There's very limited sanitation that you can do there. And also, there's a much better way to do it, which is called prepared statements with name parameter binding, right? Select star from users where ID equals :ID, or question marks as well, right? Prepared statements is the only reliable way to avoid SQL injection attacks. If you still want to sanitize inputs, that's fine, but make sure you use prepared statements. So if you use PDO, for example, that's kind of baked into that. We're going to look at ORMs as well. But so here I have a link to a cheat sheet on how to use prepared statements. So like I said, input sanitation is okay, but it's brittle and not sufficient. So your prepared statements is going to look like this. You're going to go select and then put :ID, and then you're going to call bind parameter ID to then the variable. And then it will make your system safe. So I have a link to how to do it in PHP with prepared statements and PDO. All right, now let's look at ORMs, because just because we use ORMs, we may think that we're safe, and often we're not. So we just got to be careful. So a while back on the matter.org site, there was a vulnerability that came up with the Hibernate query language. Is anybody here familiar with the Doctrine ORM? Okay, all right. So Doctrine, the DQL, Doctrine Query Language, is almost the exact same as the Hibernate query language, right? They're both data mapper ORMs. And so a vulnerability that is found in Hibernate should apply also to Doctrine. So here I have a link to testing for ORM injections. So there are two prevalent types of ORMs. You have active record ORMs, like Eloquent. Has anybody used Eloquent in Laravel? Yeah, there you go. So, and then you have data mapper ORMs, like Hibernate, Doctrine, Entity Framework, and .NET as well. And so in data mapper, a way to get owned is by doing something like this, where you have a string where you're referencing your domain objects, but then you want to compare the ID of the destination object, and then you concatenate a string right after it. This is Java syntax, not PHP, but you get the idea, right? If you're doing that, you're kind of defeating your point of using your ORM, right? The way you would do it is you would not need to compare the ID property. You can just compare the object, and behind this, and then you bind the destination object in your query. All right. So in active record, the thing to be careful with are kind of those raw methods in active record. So in Eloquent, there's things like that. You can do users equals user where raw, right? And then you inject a variable in the middle of your query, right? Again, you're kind of defeating the point of using your ORM, right? So just be careful. The good way to do it, and you can do, you stick to the semantics of the ORM without resorting to their raw syntax. Okay. If you're in Rails, there's a whole site dedicated to testing SQL injections in Rails. All right. So basically, ORMs give you an expressive vocabulary. They make the safe way convenient. However, you will get owned if you don't use them as intended, right? That happens with a lot of tools. So I just kind of wanted to call that out. Does anybody use any kind of NoSQL database? All right. Cool. So those can get injected as well. And so I have a link here to test and mitigate. You can always review that. So here's an example. This is a query that you might run, but instead of less than 0, you're going to say less than, and then you put a user input in there. Right? Well, if you do that, somebody can make that user input be this old thing here. Right? And if you do that, then it's actually a denial of service attack. It will cause 100% CPU usage, and then your nice NoSQL store is just going to go up in flames. So, and it will bring Amazon down. So, what people seem to recommend is that you just kind of cast arguments to string. So that article gives an example to cast a username to a string, cast a password to a string, but then it seems to assume that they're querying by password. That made me shivers. Do not store the password in plain text, please. We're going to touch on that extensively at the end. All right, so cross-site scripting, I'm going to skip that. But I have a lot of information on there. How you can mitigate. Boom. Yeah, biggest thing is in Symfony and Laravel, if you just kind of do this, you should be okay. So do this. All right. If you save data, try to, strip the things that you don't need. Okay, and then kind of normalize your data, use the correct data types. All right, and then I'm going to skip CSRF as well, but I have examples here. So again, your framework should handle CSRF. So here's the documentation on CSRF for Symfony, and here's the documentation for Laravel. Okay. Basically, anytime you have a form, make sure that it is protected by CSRF, okay? All right, now let's look at application vulnerabilities. So we're going to look at user authentication, OAuth security, and then access control and multi-tenancy. So user authentication, for the most part, kind of password handling. So here's a cheat sheet on OWASP. But we're going to look at a few things. We're going to look at failure messaging, failure handling, multi-factor authentication, account recovery, password policies, password hashing, password transport, session duration and re-authentication, and what happens if your account does get compromised. All right, so failure messaging, basically you don't want to be too helpful to a hacker, right? You don't want to tell them, hey, you entered the correct username, but the password is not quite right. Okay, can you try again? Right, you do not want to give them intelligence, right? So you want to keep the error messaging for all failure modes as vague as possible. You want to avoid saying things like wrong password, right? Because wrong password means good username. You don't want to say wrong user ID, because now you're saying, oh, this user ID does not exist on this system, so don't bother doing a brute force attack against it, right? Account disabled, user not active. These are generally bad. And what you want to do is keep it generic. Login failed, invalid user ID or password. Okay, so now the attacker does not know exactly what went wrong. All right, so now we're going to look at failure handling. So you want to try to mitigate brute force login attempts. So you can try to limit failures by IP address. That can be bad because if you have a bunch of people who come from the same conference, yeah, that could be bad. So you could try to use CAPTCHA on your login forms, but that's a good way to get people to hate you a lot. So if anything, you definitely want to log all failures, right? So you know what happened. Attempted user ID, timestamp, IP address. But then also remember the GDPR, right? If you log something, yeah. It's like, do you really want to protect the privacy of people who try to hack you, right? It's a big nightmare. All right, so multi-factor authentication means you can try to log in with more than just your username and password. It could be an authentication app on your phone. It could be text, like a SMS message. So the thing is, beware of SMS phone-based verification. It's super convenient, but obviously phones do get lost or stolen. SIM cloning is also a thing, right? You could go to a T-Mobile store. If you bribe somebody, you might be able to get them to clone a SIM for you. They've cracked down on that, so hopefully they don't do it anymore. But it's always a worry. In your SMS verification message, try to not say, "Here's your verification PIN for yoursite.com," because if somebody steals that phone, then now they know that, hey, they got that on there. So you don't want to give the finder of the phone any idea. Okay. Account recovery. So security questions are kind of a nightmare, right? I suspect that most sites store security questions in plain text, which kind of keeps me up at nights. You really should be treating those answers as passwords. So I have a link here to kind of best practices for security questions, but this article really says security questions are a nightmare, right? They just don't like them. But a more common way to recover an account is to do an email with a reset token. So in the email that you send with the reset password link, try to not let the token linger in the URL. Kind of redirect it away such that it disappears from the URL because it could, it could appear as the referrer if they click to some other site. So try to make the token disappear as fast as possible. And try to expire it as quickly as possible as well. And also do remember that email accounts do get compromised. SMS is also one way to do it, but again, phones do get hacked. In either case, if a user does initiate a password recovery, you should invalidate all existing sessions for that user. All right, so now let's look at password policies. So if you want to try to forbid from known passwords. So the cool thing is there are folks who make lists of known passwords, right? So every time some sites get hacked and the passwords get discovered, people capture a lot of those passwords in lists, and you got small list, big list by Daniel Miessler. So definitely look at those, and you should try to avoid people from putting those passwords. And then definitely try to forbid users from reusing one of their last 5 passwords as well. These days, the password length should be 10 characters or more. Obviously, the more, the merrier. I have run into sites where I would put like, a 20-character password, and they're like, your password has too many characters. And I'm like, what now? Not good, okay? Password should be long, the longer the better, all right? Let people put in really long passwords. Your password should not contain a username. For some reason, people do that. And you should try to use at least 3 of the 4 available character types. Lowercase, uppercase, numbers, and symbols. So try to use at least 3 of the 4 of those. And then try to consider making users change passwords, every 3 months. Although, we try to avoid that because, you don't want to. You want people to stay engaged with your site, so it's a bit of a trade-off there, obviously. Okay, password hashing. Is anybody here familiar with password hashing? Okay, all right. So the good thing about password hashing is you can assume that your database has been stolen, and then your users' passwords cannot be compromised. Don't use any of the one-pass hashing algorithms, like MD5, oh yeah, not MD5, or just SHA, right? You want to use an industry standard hashing framework, which will do multi-pass, which will put constraints on the CPU, and also constraints on the memory. And we're going to look at that because, and then the other thing that these frameworks will do is create a unique salt as part of the hash for every user, right? So they do that work for you. So I have been using bcrypt for like ever, and it's still okay. But the thing is, some researchers have found that with bcrypt, because of all those GPU processors now, you can still crack a lot of passwords pretty fast with some of the more powerful GPUs. And so researchers identified the need to put some memory constraints. So bcrypt did multi-pass, and it put constraints on the CPU. But now to counter GPUs, they want to put constraints on the memory. And this is where the Argon 2 algorithm came out a few years ago. So it was the winner of a password hashing competition. And PHP is one of the few languages which has been supporting it for a while now. So it was baked in PHP 7. So if you look at password hash in PHP, you'll see Argon 2 as one of the algorithms, okay? So I'm still using bcrypt on a lot of my sites. I need to switch to Argon, and I haven't gotten around to do it. So hopefully I don't get cracked. But So I have an article by David Whitlock that compares the benefits of Argon 2 over bcrypt. So it's definitely worth a read. Yeah. So transport. Obviously, anytime you have sensitive information transiting, you want to use TLS. So has anybody here used let'sencrypt.org? Yeah, it's pretty cool, right? Free TLS certificates. Love it. So definitely try to use TLS for everything, but definitely obviously for login and registration and password recovery, right? Now, does anybody remember kind of the OpenSSL vulnerabilities in the last few years? Like Heartbleed? Anybody remembers Heartbleed, right? Okay. Well, sometimes TLS can fail us, right? So I've started working a little bit with a JavaScript library called JS Encrypt, and so it supports public private key encryption, similar to what you would do with TLS. But what you can do with this setup is you could use this client-side JavaScript library to encrypt the user's password on the HTML page before it gets sent. You can encrypt it with the public key, and when it gets to the server where you have the private key, you can decrypt it, right? You're still going to use TLS to submit the form, make sure that the network layer is still TLS, but on top of that, you've got your own layer of encryption on top of that, right? So if somebody finds a vulnerability in OpenSSL, and they look at your traffic, they're still going to see junk because you've already encrypted that, right? So it's kind of like super paranoid, 2 layers of security. I don't like to trust people, so there you go. All right, so session length and reauth, try to keep your sessions as short as tolerable. So, for example, does anybody here go on Amazon.com? Or Amazon.de, right? Okay, so on Amazon, you're always logged in, right? It always remembers who you are. It's always doing recommendations for you. But when you check out, right before you check out at the very end, that's where you have to re-enter your password, right? So it's a really good practice. You can keep users logged in for non-sensitive interactions, but for what's transactional and sensitive, then yeah, try to force a reauthentication, kind of a different, shorter-lived session. So that's that. Compromised account. So try to have an event log to log things. So it should be a data store that's separate for your main application's data store. It could be a NoSQL store, so it'll be a bit easier to scale because you're going to get a lot of those events, possibly. And definitely have separate credentials from your main application. You can scale it independently. And the key is to gather forensic evidence when people interact with your applications. When people log in, whether they're successful or not, because if an account got compromised, you want to see what they're doing in their account, right? So an event log can help out with that. But obviously, again, you have to look for GDPR compliance. You still want to allow people to be forgotten, and I just don't know how to handle this within an InfoSec context. So, all right. That was a lot. Here's a puppy. That's my dog, Archer. All right. So now let's look at OAuth security. So there are 2 concepts. There's authentication, which means who am I? And then there's authorization. What am I allowed to do? When OAuth 2 first came out, it only cared about authorization. Okay, and it left authentication as an implementation detail that it did not care about. So this is where OpenID Connect came out shortly after. And OpenID Connect is technically a specialization of OAuth 2, and it defines standards for the things that it kind of left up to the implementer. So it adds authentication and a lot more, and it's OIDC is widely used by social media sites and many web applications. Phone apps as well for authentication and authorization. So OIDC supports 4 grant types: auth code, implicit, resource owner password, client credential. It's important to study those grant types. I have an article here by Keith Casey. He kind of describes all of them and kind of what the better use cases. The implicit grant type gets used quite a bit for single page applications. Some phone apps, and the idea is the user login and password is not persisted on your single page application or your phone app. The flow kind of looks like this. The user opens the application. The application is like, I don't know who you are, so it redirects the user to an OIDC provider, where the user is prompted with their username and password, and also, do you want to allow the site to get your information? If the user passes all that, then the provider sends a token back to the user, back to the app, which can then the app can send that token to your API, which will validate the token using some shared secrets that it has with the OIDC provider. So the key here is that the areas in pink are your code, and this blue box is most often some other framework. or a third-party provider. So what you want to make sure is that you're using TLS for all communications. There's a redirection that happens here. You need to prevent arbitrary redirection to happen. You need to make sure that the destination URLs for redirection is whitelisted. So this is what it means. OIDC must register valid redirect URLs. You want to have proper token validation. If you're using JWT tokens, try to not have any sensitive information in them. You really should not need that. And then try to store your JWT tokens as HTTP only, such that if your application gets compromised at the JavaScript layer, then JavaScript cannot read the JWT token. Try to use well-tested client libraries and well-tested OIDC servers. Try to not roll out your own. It's a pretty terrible idea. There's a lot of really good open source alternatives, including Identity Server 4. That's a framework implemented in C#.NET. But in PHP, you have OAuth 2 by the PHP League, so you can use that as a foundation. I've used also Friends of Symfony, the FOSS OAuth server bundle. And then for client middleware, you've got Passport.js, and there's also OIDC Client.js. So there are a lot of open source alternatives. This slide, that's the one slide that I don't have in the PDF yet because I just kind of added it today and I try to upload it. Hopefully I will have it tonight. Okay, so now let's look at resource access and multi-tenancy. So I have a link to the OWASP site that kind of describes that. But basically, in your application, if you have a user report, by an ID, right? And that's my report. Well, what happens if I change a number, right? If I add 1 to the number, am I going to see somebody else's report, right? You got to make sure that whenever you access a resource by an identifier, that you enforce the business rules to make sure that whomever is logged in actually has legitimate access to this resource. Okay, I find this mistake in a lot of applications. It tends to be kind of an afterthought. So be very careful, right? Some people say, oh, but we should just be using UUIDs because UUIDs cannot be incremented or guessed. Here's the thing, though. There's this little thing called HTTP refer header. It is possible for somebody to be viewing a resource with a UUID in the URL. Then you're linking to some other site from the footer. Somebody clicks on the footer, and that UUID URL shows up at the referrer and the next site. Okay, so UUIDs are security through obscurity. You do not want to use UUIDs for security. It's not what they're meant for. Okay. Yeah, so multi-tenancy is a thing, right? So if you're building a SaaS product, not only are you going to have multiple users in your application, so you don't want one user to see information from another user. You don't want that. But it's even worse if you have multiple companies and you have an employee from one company seeing data that belongs to another employee from another company, right? That's even worse. So you don't want that. Again, you want to make sure you enforce your business rules. All right. So now, as we get close to the end, I want to get into some architectural considerations. Securing your data stores. Whether it's SQL or no SQL, do not put your data store on the internet. Okay, there is no valid reason for your MySQL database or your MongoDB database to have a public IP that is exposed to the internet, right? That does not have some stringent firewall rules. You want to put your data store on a private network with a web server, and really the only thing that should be able to connect to your data store should be your web server. Make sure you set passwords on your data stores. Turns out that a lot of people put MongoDB databases out there without passwords. Like, they literally do that. And you've got thousands of them that got compromised. What's even worse is people build applications with a Mongo database on a public network with no password, and then they have a phone app that talks directly to it. Okay, it is scary. There are a lot of those out there, and they get compromised a lot. So please don't do that. And so when you're working with a data store, try to apply the least privilege principle. So if you look at MySQL, for example, you can create a root user that can do anything. Drop tables, create tables, alter tables, right? Your day-to-day application should not need to do that. Right? The user that runs your web application should only be able to do select, insert, and update of records. You might allow it to do deletes, but ask yourself, do we actually want to delete records? Or sometimes do we just do soft deletes of records where we update, a deleted field on a record, for example, right? So also it's a good idea. Does anybody here do master-slave replication? Yeah. So it's pretty typical to create a read, to have like a read database with the read credentials and then write credentials, right? And if you do that, it's a good idea to only allow your read user to do selects and then only allow your write user to do insert and updates. So if your application gets cracked through the write user, they can't really select data. And if it gets cracked through the select user, then they can't modify data, right? At least you mitigate the impact of things. All right, so now let's look at the network design a little bit. Anytime you put a machine on the internet, you've got your operating system, you've got the daemons that run on top of the operating system. Then you have your application frameworks that run on top of the daemons. Then you may have some framework plugins. Then you're gonna have your code, right? So anytime you put a machine on the internet, that's kind of the vulnerability stack you have to worry about. And so the first thing that attackers are gonna do is they're gonna do brute force attacks with like low-level like buffer overflows against your daemons and then brute force credentials, right? Once they do that, once they get in, then they can compromise the operating system, which means they can compromise your entire application. Okay, and then conversely, attackers can go in through your OAuth-based vulnerabilities, right? Your web application vulnerabilities, and if they're successful in many cases, then it allows them to compromise the rest of your operating system. Okay, so whenever you design your network, just try to be very careful with to isolate everything. So let me show you a wildly insecure setup, okay? You have your data store on the open internet. You have your web servers on the open internet, and then your load balancer, and then you have another data store with a bunch of web servers, and everything is on the open internet. Okay, so you may have a load balancer here, but attackers are gonna say, cool load balancer, bro, and they're just gonna go around it, and they're gonna attack your web servers and your databases, and they're gonna do low-level hacks, high-level hacks, right? You're gonna get owned, right? You do not wanna put all these things on an open network. A more secure approach might look like this. You have your private cloud, inside of which you could have another private network for your first application, and then another private network for your second application, and then you will have a data store with a couple of web server inside those private networks. Same thing for the second application. Then you're going to put your load balancer in front of your cloud network. And then you're going to have firewalls in between your data store and your web servers, and then your firewall between your load balancer and your internal network. So basically, and then you're going to, you might have a VPN 1 and a VPN 2, such that DevOps can go in and administer these systems. Okay, but now technically, the only way attackers can get into your network is through your load balancer. That's it, right? The only way they can attack you is through ports 80 and 443. That's it. right? They can't try to go around to all these machines. So, the benefits are obvious. I just kind of did it here. Another big thing is securing credentials, okay? Do not put your credentials into your Git repo, please, okay? It happens a lot, more than you think. Whether it's your data store, your MySQL password credentials, you do want to put that in your Git. You do not want to put your Amazon AWS keys. Do not want to do that. Any kind of third-party API credentials, you don't want to do that. Is anybody here familiar with the .env files? Yeah, they're a good thing to look at. They work cross-platform. It's a good idea. Has anybody here played with Ansible Vault? Yeah, it's another pretty cool thing to work with. So look at these things to secure your credentials. Okay, so in the end, InfoSec is a mindset. When somebody gets owned, do not laugh at them. It's our collective responsibility, from executives to managers, software engineers, DevOps engineers. We all own security, right? It's not a DevOps thing. It's not a developer thing, right? We all own it. I recommend subscribing to InfoSec mailing lists. Here are the a few of them to which I subscribe. InfoSec News, Full Disclosure, Bug Track, cert.gov. Well, that's for US, but yeah. So, like I said, when someone gets owned, read their case studies and find what's applicable to us. Don't laugh at them because, yeah, it could be us tomorrow, okay? Thank you, that's it.